I've been looking for a good way to provide our students with an opportunity to be able to learn about Mecanum wheels and the code that's needed to drive a robot that uses this wheel configuration. I found a set of small Mecanum wheels that haven't been used. So these would be perfect for a small robot that could be the basis of something like a RoboCup Junior Maze or even a RoboRave firefighting robot. So Mecanum wheels are really interesting. I'm planning on covering the math and the basic code needed to drive them in an upcoming video. So our FTC team from 2019 made use of them, and I'm really keen to keep some of this learning together for our future teams. So I hope you guys get something out of these videos. Now the only issue that I found with these wheels is well, we don't actually have any couplers that can fit this size wheel matched with the 6mm D shaft of the spare motors that I have. If only there was a way to design a component that could match the specifications of both parts and magically make it. So we can measure the wheel connection and then 3D design the part. Today we're going to be using Tinkercad, and our wonderful Rebecca was kind enough to go through the steps of making the coupler, which you can see now. So Tinkercad's a really powerful tool, not just something that young kids can use. So don't be afraid to tackle some real world problems with this tool. So after the 3D design process is done, we need to slice the model for printing. So notice how we have some horizontal overhang. If we tried to print this as it is, we'd be printing some of this model into the thin air. And molten plastic really doesn't like to hover. So we need to enable some supports to give the part something to keep it in place. So you can see the supports in the preview. So once the coupler was designed, we moved over to the 3D printer and let it do its thing. So in our next video, I'll talk more about the coding that goes into making this robot move. The logic will be the same as what we used in our larger FTC robot, but rather than coding in Java like we did for FTC, I'm going to use CircuitPython for this robot. Until next time, have fun!